All right, hello calculus class. This video is about how to do the next assignment, the review assignment starting on page 255, 11 through 15, 21, all that kind of stuff. So I'll just kind of help you out with that. Let's see, so the first ones, 11 through 15 here, they're just regular derivatives, product rule, quotient rule. Number 13 is by probably implicit, so you gotta take it implicitly, so just practice with that. Again, you should have the answer, so you can check that. Let's see, 21 was over here. Okay, I'm lost. 21 is the same thing. 21 is definitely implicit, so good practice with that. Hopefully you can figure that one out. And then see 31 through 35 odd. Again, just practice doing derivatives. So remember, f double prime means a second derivative for number 35. So you take the derivative twice, take the derivative of the derivative. So that should be okay. Let's see. Number 41 is just a tangent line one. Find the, so you guys, take the derivative, find the slope. Looks like a product rule going on there, so be careful with that. But that one should be okay. And then 49 through 55 are a little bit weird. They're these guys here. So I will go over that one. I'm going to do the even ones. Let's just try to help you out with the odd ones. So the idea is they want you to find what the derivative is, but they don't tell us what the function is. They just say f of x is g of x squared. So all you do is you just take the derivative. So if f of x is equal to g of x squared, and these are all just applying the rules of derivatives, not really getting an answer. So the derivative of x is, and this is just a chain rule, it's first you take the derivative of the function g prime of x squared, and then you say, oh, inside is an x squared, not an x. So we multiply by the derivative of what's inside, so the derivative inside is 2x. So that's it. Okay, that's number 50. So let's look at number 52. F of x is g of g of x. So again, this is just a chain rule. So the derivative f prime is the derivative of the outside, g prime of g of x, and then we say, oh, the inside is g of x, not x, so we multiply by the derivative of the inside, which is just g prime. So again, these are just applying the rules. They're not hard. They're just kind of, okay, 54. So f of x is equal to e to the g of x. Take the derivative. Derivative of e to the anything is e to the anything, e to the g of x, and we say, oh wait, it's a g of x, not an x, so we multiply by the derivative of that, which is g prime of x. These are actually easier than other ones because you don't actually have to take the derivative, you just have to say it. And then 56 is another chain rule, f of x is g of ln of x. F of x is g of ln x. I think that's the way it's written, the f of ln x. So again, the derivative is just f prime of x is just g prime of ln of x times the derivative of what's inside, which is 1 over x. Okay, that's all. So the odd ones are just the same. They should go really fast. I know it seems like there's a lot of problems here, but they go really fast. It's not so much work. Okay, that's, oh, by the way, like looking at number 55, the one that you guys have to do. So 55, they say that f of x is equal to ln of g of x, and in absolute values, that's an absolute value there. So the derivative of the ln of an absolute value, they work it out earlier in the chapter. Basically, you can ignore the absolute values. The derivative ends up being the same as if the absolute value wasn't there. So you don't really need to worry about it. So there's a lot of problems like that. If it's an ln of an absolute value, you just take the derivative as if the absolute value wasn't there. And kind of putting the absolute value there means that it's forcing it to be 0 or greater, actually greater than 0, because you can't have the natural log of a negative number. So that's just saying, okay, yep, we know that. So anyway, you can ignore them, which is kind of nice. So that makes that one easy because it looks confusing, but it's not so bad. Just ignore that. Okay, then what else is there? Number 61. Number 61 says, right, find the points on the ellipse where the tangent line is slope 1. So you just take the derivative. There's two ways. You could do it implicitly, or you could do it explicitly, or you could just solve for y and take the derivative. But then you just set the derivative equal to 1, because where this tangent line is a slope equal to 1, so you set the derivative equal to 1, and then find the points. So that's how you do that one. Hopefully that one's not so bad. And finally, the challenge problem, which I think you guys could do, looks kind of fun, is this one here. So you want to find the center of that circle. And I haven't done that one before, so I'm waiting for you guys to show me how, but definitely looks like the circle at those points is equal to the parabola. So we know the equation for the circle. We know that it's, let's call that point there the center. Okay, I don't want to write in my book, but let's call the center h comma k, which the y value we don't know, but the x value is 0, so it's 0 comma k, and we want to find k. We want to find where that y value is. So that's what we're finding here, right? We want to find k. So we know that the equation for the circle is x minus the center, actually this would be h, x minus h squared plus y minus k squared equals the radius squared. The radius is 1, so that's just equal to 1 there. This is 0, so it's just x squared plus y minus k squared is equal to 1. We want k. We also know that the circle equals the parabola at those 2 points. We want to find when the circle equals the parabola. So that's y equals x squared. So we could set y here equal to x squared. So plug in x squared there. And it looks like we know that that's that point, that slope of that line there, that's the radius, so it's perpendicular to the tangent line of the parabola at that point. So we can also use that. And so by using those things, you hopefully should be able to figure that out. So good luck. I think you guys can do it. Okay, if you have any questions, just let me know. It's real easy on Remind to just quickly text me a question, and I can either answer it or decide. Probably a lot of people have the same question, send it to everybody, but hope everything's going well. And good luck with the assignment, and again, let me know if you need any help.